Hello, my name is Raghav, and I'm applying to become a Comp 1511 or Comp 1531 tutor. In this video, I'll be showing you how I teach, in particular 1511, because um, I just want to split the videos in parts. Um, so I'll just be going through this. If you can see on the screen, I'll be going through this practice exam paper I found on the course website, 25 term 3. And I haven't really looked at it. But I did have a read of this question 3. So yeah, and I copied down some questions. I copied question 9 down. Um, Let me ls. Yes, you got copy question 9 now. But let me just start with some basic command, teaching some basic commands on the Linux terminal. So um basically, if I have this practice 9 question, and as you can see, I haven't done anything for it. Um, I want to remove this file. So the way you remove files is you go arm, which stands for remove, and then it's a file, so you can just like forcefully remove it. It won't ask you. So you go prac, and then you can press tab. Now you can see that when I press tab, you only did one of the files, so you can write like remove multiple files in the same line. So yeah, and tab auto completes it. So yeah, so you can see how it auto completed, and now I press enter. It should remove the files. So go ls. Ls is the way of looking at all the files and directories in a particular directory. Yeah, you can see ls is teach is empty. So you want to go cd is the way you access into a directory. You can also use cd to access out of a directory. So if you go cd dot dot space dot dot, and it'll take you back one directory. If you go cd, go teach again, tab, and you go cd, it'll take you back to the home directory. So firstly, let's go into documents, and then let's ls, and I want to show you how to make a directory. So you go cd, so you go make the teach the, right. um it already exists. I'm gonna make teach the one, and I can see ls, and you can see a teacher there. Now I showed you how to remove a file. I didn't show you how to remove a directory. To remove a directory, you go rf, so it's just an extra letter, and teacher, and now I'll remove teacher. Now you can see the teacher is gone, and now you can like begin writing some code for teach the one. So it says, as you can see, it's empty, and I don't know why question 9 is showing up. It should have deleted. I think it just hasn't refreshed. Yeah, look, now I can see that it had refreshed. So what I want to do is going to do question 3 first. So yeah, let's skip 1, 2, let's go question 3. And let me explain linked lists. So you can copy paste that into here. Yeah, and you can see it's in this directory. The reason you want to be using directories is suppose I copy pasted all my code into here, then I'll have like multiple subjects codes like in the same file, which you in the same like directory. You don't really want that, because you want like some sort of structure and cleanliness when you're maintaining code. So this is one of the methods to like keep your code in different for different subjects. I even have, if you look at my com2521, you can see that it's assessment 1, assessment 2, assessment 2 save, so that they're all like split up, week 1 lab, week 2 lab. So yeah, it's good to like split your code up like that. So cd dot dot, go back, cd, you can cd into a directory, going cd, and let's go teach the, that's how you go into a directory. Yeah, so let's open on this practice question 3. It hasn't uploaded. Yeah, 1 second, let me just refresh the code command. Usually in your Tiger VNC, you can write code and then question 3. It'll open it up, but for me it doesn't work because I'm using SSHFS. So because it's my home computer. So basically, yeah. So let me not write anything down yet. Yeah. So basically, as you can see, this is this is they give us some pre-existing code. This they give us this data structure, a struct. Basically, a struct is a data structure that it contains many variables, and you can like group them together. So this in particular, you can see this is a linked list because it has a pointer to the next node, and that's very typical of a linked list. Binary trees also have it, but they have left and right. So let's just stick to linked lists. So um, struct node, yeah. So basically, struct node is a variable type, and it contains these variables. So so you can see that a node contains a int data, so the type of integer a data, and it contains a pointer to the um, next node. So why do we use pointers? Well, the system automatically uses pointers. We just haven't like seen it like properly. So you can see this when you make a string. So you go string. Let's just ignore this code right now for now. You go here and you make a string of suppose 1,000, right? So usually you shouldn't be doing this 1,000. Like you want to do something like hashtag define max string len, and you're gonna go 1,000, something like that, and then you want to, because it's suppose you look at it again and you don't know what this 1,000 is for. That's why you really don't know you're doing that. So when you do this, there's no way your computer can. I mean, it can, but usually you won't be able to find a space in the heap. So in the heap, which is your memory, you won't be able to find a space where I can put 1,000 character spaces right next to each other. So it won't be able to access it like how you access it. You go cast string one, and then sorry, you go 0, and then 1, and then 2. So yeah, it starts at 0, by the way. So 0, 1, 2. So you won't be able to how you access it. It's not how it accesses it. It basically stores it with pointers. So it gives you suppose like 20 bytes. It finds a space of 20 bytes. It not 20 bytes. Sorry, it finds the space for one string character, and then it points that string character to another address. So that's basically what a pointer is. And your actual computer is actually using it in the background. You just don't see it. So when you do something like this, it's actually doing it in the background. And then that's how it gives you that space. So that's how it efficiently manages space. Otherwise, it would just have chunks of code, and then you have empty spaces right next to it because it can't fit other bigger spaces right next to it. So that's how it manages its memory. So it's kind of similar or what you're trying to do, but you're physically doing it instead of the computer automatically doing it for you when you're using a pointer. So um, this pointer basically is a variable type that points to an address in memory. Now, um, that is how a linked list is created. Basically, your pointer is pointing to the next node in the list, and then your next node is pointing to the next node in the list, and then it goes all the way to the last node, which points to null. And over here, we can see that they want us to find. Let's just do this question. So they want us to find return 1 if our list contains even and odd. Otherwise, return 0. So otherwise, return 0. Let me just make this 0. That's why I was deleting the code before. And okay, we don't need this string here anymore. Let me get rid of that. Okay, and we don't need this, so we don't confuse ourselves. So basically, we want something to indicate that we found an even integer. So found even, we can set it to 0. Int found odd, we can set it to 0. Now I'm using camel case here. Typically you want to be using camel case, or you want to be using like underscore and then spread out, but you can see that doesn't look that good here. I typically like using camel case for something like this. You know, when defining functions, then I would be using like the underscore here. So int found even equals 0, int found odd equals 0. We set it 0 because we haven't found them, so that's like a basis. Or you could use the bool, but you have to use a bool like you have to use a hashtag include another library that has the bools, the boolean library. Here they haven't given it to us, and because it's an exam, usually you won't be able to hashtag include a library. They don't allow you to. So yeah, so let's start. So we haven't found an even, we haven't found out. First thing you have to do is you have to iterate to the list. Now, would you use a for loop or would you use a while loop? Um, Here I would use a while loop. Now, why would I use a while loop? This is because for loop kind of doesn't make sense because you don't really know how many linked. Usually, you don't know how long your linked list is, right? So, um, you, I mean, unless it's stored, and here you can see the struct linked list doesn't store how long it is. So you don't know how long the linked list is. When you try to do I is less than some number is somewhere here, you don't know what that number is. So it's kind of not useful to do a linked list. You rather really want to be doing a while loop, and you can okay. So let's do while head is not equal to null. So this head pointer has given us which points to the first node in the linked list. We don't want it to become null. So when it equals null, we want this loop to break. Now, what is the problem of using head? What's the problem in this code? So the problem of this in this code is we use head, which is not good. And why it's not good is because look. So suppose you have to modify head because how else would you go through the linked list? You have to do head. At the end of this, you have to go head equals to head next, right? Because you want to access the next. Now I'll explain why you use this arrow, but just assume that this points to the next node in the list, right? For now. So this head, we need to point it to the next one in the list. That's how we iterate through. So one is at the one, it checks one is odd, then and then it checks two is even or odd, checks three is even or odd. So we're moving down the linked list, right? So that's why we have to move down. Now the problem with using head is we can use head here in this example. It wouldn't matter, but we usually want to save the head because suppose you want to do something else to the linked list. So usually we do a struct node type. We do current node, right? And this is a pointer to the same address the head is pointing to, right? And and that's how we can get something that we can modify. So we can let that current node, and also makes it's way more readable. So it's like a code is way more readable here because you know what the current node is. But if you had put head and you modify head, someone who's directly looking at the code isn't like really sure of what like the what head is. Suppose if it was not called head something else, so they don't know why you're modifying head. So it's not standard to modify head. So you check while current node is not equal to null. Let's just finish off this question. So while current node is not equal to null, current node. Oh yeah, I haven't explained why I said assume this arrow instead, right, to access the value next pointer. So basically, usually how you access elements of a struct is you go current node dot. Suppose it was just a struct, there was no pointer, so it was struct node current node, right? So how you access the variables is your current node dot. So how do you access int data? So you go data, right? And that's how you access the value. But over here, because we have a pointer, we usually have to do pointer current node, and then you do dot. So you have to do dot like this, and then you have to do data. Now this is slow and it's too many variables. So because coders are lazy, we just, you know, use an arrow instead. It's much simpler, looks much nicer, and that's why we use the arrow. So we firstly don't want to be moving to next. We first have to check if the value of our current node, so if current node data is when it's divisible, when it's divided by 2, so modulus 2, it gives a remainder of 0, right? And if that happens, you have to make found even equals 1, right? Which indicates that we have something in the linked list which is even. So, and you can go if else. Similarly, you can go here and you can check current node data. And when you divide it by 2 for an odd, because an odd is always 2 and plus 1, you can just check if the remainder when you divide by 2 equals 1. So you use double equal sign because the first equal sign is your assignment. The double equal sign is a check. It's a conditional. So if you suppose if you over there you did current node data equals 1, then you're making the data equal 1, right? But if you did current node equals 1, if, so you're checking if it's 1. So if you do something like this, over here it'll fail, but in the if conditions, it's a conditional. So you have to make it equal, right? So that's what you do. So you check if it's odd. If it's odd, you return found odd equals 1, right? So now we have checked, we're iterating through the whole loop, whole linked list, and each time we're checking, is this equal to, is this divided by 2? Is this divisible by, is this divisible by 2? Yeah, or is this divisible, divides, when 2 divides this, it gives 1. So which means it's odd or even. We're basically checking that. And we're iterating through the whole loop. Now we have to throw if found even equals 1, and you have to find both even and odd. So found odd equals 1, we return 1. Else, you can write else return 0, right? Or you can just ignore this part and you can just return 0 if it fails this check, right? Also, something you can do for like more clean, neat looking code is something, make this a one-liner. So something like that. That's readable and it's short as well. So it's short and sweet. So yeah, this is how you do it. And I think this should work. Let me just, you can test it like this. So I'm just test it, see if it works. So oh, it doesn't work. Oh, see, you can see, and this is how you debug. So this helps you debug. You can also use print statements to debug. So you can see that I missed a semicolon here, and 10 tests could not be run. Let's see now. So nice. See, as you can see, it's working. Over here, your tests are passing, and or if you want to do a test, test your own specific case, what you can do is you compile. You basically C works. C's first it's written, and then you compile it after. So it's compiled as language that gets compiled after. So for a language that so it's like something like Python, it gets compiled one line at a time, which is why you don't have to run this DCC compiler, or like usually after in 2521 you lose like CLang. So use DCC, right? And then you write the name of the files, which is prac tab, and auto completes -o, and you go prac question 3, not C, get rid of C. There you go. And this is going to DCC compile for you. So it's going to compile the code into machine code, which the machine can read. So then you ls, you'll see this second file that's created, right? Now what you have to do is execute that file. So prac question 3, and let's run it. So we got 0. Why? Because we didn't input anything into it. So we want to do input 1, and suppose 3. It should give us 0. Yeah, it gives us 0, and let's test. So 1 and 2, and it gives us 1. So yeah, we can see our code is working. Okay. Yeah, that's this for this question. I'll make another video for a harder question.